This is the lecture video for section 6.3. This is a video 2. Here we're going to be talking about equations involving double angles. So the first example we have is we want to solve the equation cosine of 2x equal to sine of x over the interval of 0 and 2 pi. So to solve it, I'm going to first looking at the equation cosine of 2x equals to sine of x. I cannot really solving them using linear way, using factoring or anything we talk about in section 6.2 because we have both sine and cosine and one of the trig functions having 2x. So I'm going to using the double angle formula where cosine of 2a equals to cosine squared of a minus sine squared of a. So I'm going to replace cosine of 2x as cosine squared of x minus sine squared of x equals to sine of x. Now I'm going to kind of changing the equation a little bit. I'm going to have in cosine squared x equals to sine squared x plus sine of x. Okay, so by switching them, I see that I have part of the equation using only sine function, the other part of equation using only cosine function. Still for the same thing, I cannot really combining them. Then I'm going to use an identity, which is sine squared theta plus cosine squared theta equals to 1. Not using it directly, I'm going to twist it a little bit to get cosine squared theta, cosine squared x equals to 1 minus sine squared x. So I'm going to replacing cosine squared x with 1 minus sine squared x equal to sine squared x plus sine of x. So you can see now everything is written in terms of sine of x, just to kind of making it more polished. So I'm going to minus 1 plus sine squared of x on both sides. So I end up with 0 equals to 2 copies of sine squared x plus sine of x minus 1. Here you can choose to use quadratic formula or you can choose to factor it. I'm going to factor it because this is a really nice quadratic equation. So I can factor it into sine of x plus 1 times 2 times sine of x minus 1. Using the zero factor property, that tells me that sine of x plus 1 equal to 0, or 2 times sine of x minus 1 equal to 0. Solving them individually, I got sine of x equal to negative 1, and 2 times sine of x equals to 1, sine of x equals to 1/2. Sine of x equal to 1 tells me that x is going to equals to 3 pi over 2 in the interval of 0 to 2 pi. Sine of x equal to 1/2 tells me x is going to equals to pi over 6, that is in quadrant 1, and also 5 pi over 6, that is in quadrant 2, because both give me sine of x equals to positive 1/2. And those three answers are the only answers in the interval 0 to 2 pi. So my answer is going to be 3 pi over 2. I'm going to order it from the smallest to the largest. So pi over 6, 5 pi over 6, and 3 pi over 2. The next type of tricky equation using double angles are like example 3. I want to solve 2 times cosine of 2x equal to negative 1 over the interval 0 and 2 pi. So for here, we can see it. I do have a double angle cosine of 2x, but I do not really need to use the double angle formula, double angle identities. I do not need to change cosine of 2x into cosine square and sine square. And particularly because this case I only have cosine, I do not have anything else. So I can use the linear way to solving it. So I have the equation 2 times cosine of 2x equal to -1. And I can divide by 2. I got cosine of 2x equal to -1/2. To make it more clear, I'm going to let u equal to 2x. So cosine of u equals to -1/2. Cosine of u equal to -1/2, that tells me u has a reference angle of pi over 3. But because it's negative, that means in quadrant 2 and quadrant 3. One thing before I continue, I need to point it out is the original question tells me that I want to find x over the interval 0 to 2 pi. That means x is going to be between 0 and 2 pi. But our u is 2x. So 2x will between 0 to 4 pi, which is u will lies in between. So keep that in mind. Then when I'm talking about in quadrant 2, my u can equals to 2 pi over 3. And also 2 pi over 3 plus 2 pi. Because u is in between 0 and 4 pi. To solving them, u equals to 2x. So x will equals to divided by 2 pi over 3. And u equal to 2 pi plus 3, 2 pi over 3 plus 2 pi, 6, so 8 pi over 3. Then 2x equals to 8 pi over 3 divided by 2, x equals to 4 pi over 3. In quadrant 3, we will have the very similar situations. U can be equals to 4 pi over 3. And because of u is ranged from 0 to 4 pi, u can also equal to 4 pi over 3 plus 2 pi. U equal to 2x, so 2x equal to 4 pi over 3 divided by 2, x will equal to 2 pi over 3. And u equal to 4 pi over 3 plus 2 pi, which is 10 pi over 3. And then 2x equals to u will equals to 10 pi over 3, x will equals to 5 pi over 3 divided by 2. So for this particular question, our answer will be 4 solutions. From the smallest to the largest, I will have pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, so I showed you 2 different examples involving double angle problem.